Okay, this is the third video from the homework from lesson 10.1. In this video, we're going to find the area of a rhombus, and here's what's given. You're given that one diagonal is 14 inches, and you're given that a side of the rhombus, and remember all the sides are congruent in a rhombus, is 25 inches. Recall that the formula, which we just talked about in the previous video, prior video, was the area for a rhombus is 1/2 the product of the two diagonals, d1 times d2. Well, so you look at it and go, well, I only have one of the diagonals, it's 14. Okay, so what do we need? We need the other diagonal. We need to ascertain this other diagonal, this unknown d2, okay? So here's the couple things. One, remember that, in these textbooks, there's always enough information for you to figure out what you need to get. They're not gonna leave you high and dry, okay? And two, when in doubt, kind of remember that in geometry, at least at this level, most things boil down to triangles, okay? It's all going to fall back on triangles. And for figuring out triangles, you get Pythagorean theorem, and if you need it, trigonometry, okay? In this case, recall your Pythagorean theorem, and particularly, I hope you remember when we talked about Pythagorean triples, your well-known whole number dimensions for right triangles, okay? I should have mentioned, of course, kind of left this part out. How do these diagonals intersect? As we should know, they intersect at right angles. So not only do they bisect each other, they're perpendicular bisectors of each other. They intersect at right angles, creating 4 right triangles. So if we can figure out the dimensions of let's take one of these right triangles right here and be a little clever about it, okay? We can do this problem pretty quickly. So if this entire diagonal, okay, is 14, then this leg of this top right triangle here is 7, right? You're all with me on that, right? Okay. So I'm going to erase that 14 and put a 7 and a 7, okay? Right? 14 completely, but 7 is a leg. Now, recall your Pythagorean triples. So remember, these are right triangles whose dimensions are all whole numbers, okay? As you recall, some of the most famous ones that come up a lot are the 3, 4, 5, all right? You got the 5, 12, 13, right? Textbooks love that one. SAT tests love that one. The 8, 15, 17. And then the fourth one of the 4 that I've told you guys, and I said textbooks love to throw this one at you, is the 7, 24, 25. Now, if you didn't remember that, you could work it out and you could solve out for this dimension, call it x, okay? And you would get that that's 24. But we want you to know, we want you to recognize, put it that way, we want you to recognize that this is a Pythagorean triple. That's a 7, 24, 25, okay? So there you go. So now you know that's 24, so you know that's 24. So I'm gonna let you take it from here. You know all you need to know. Diagonal 1 is 14, diagonal 2 is 48, and plugging those two values into this formula, 1/2 times 14 times 48 should give you an answer of, I believe, you should get 336 inches squared. Okay, make sure you work that out on paper, but that'll be what you get. Okay, hope that helps.